So here I have created a new scene, and I will use the scene for my list. So all I have here so far is just a camera. Let's close that up, and I'll create a new script. Call it list demo. Just let it compile for a second. It should appear here. So there's my list demo script, and I can open it. And so all I want to do here so far is just store a game object. Game object. I'll just make a square sprite, and I'll make it public. Here we go. So now I want to create the actual object, and I will just create a simple square sprite. So we are going to look at sprites, square. So there it is. I will add it here. I think I can keep it white for now, and I think I'll make it into a prefab, so I can just generate it from my project. So if I go here on my list demo script, I can add the object just like that. So now it's added to the script, and I want to generate a bunch of them. So let's do it this way. So normal instantiation would be so instantiate a square. So you need to set its position. So I can do it. Let's say it's vector 0, so just in the middle of the screen. And rotation, I just want to keep just initial rotation. So now if I press play, it should instantiate that object. Okay, and there's my sprite. I just created it dynamically. So now I want to make a bunch of them using for loop. So what I can do is I can create a for loop for integer. So this will be my, let's say, x position, and it's equals to 0. And then I can say if x position is less than 10, so I'm just entering arbitrary value here. So I'm just saying I want to run this for loop 10 times. Then x position increases by 1. And in here it will run the script 10 times. And every time I want to pass my x position as a value of the x. So new vector free, and it's going to be x position here, 0, 0, like that. Okay, so yeah, I'm running a for loop 10 times, and every time I'm instantiating an object, it should have a different x position. So let's try that. Okay, and I have 10 squares, and they're all 1 unit apart from each other. And then we can add something like an offset. So float offset, and I just want them to be 1 unit apart plus, you know, a little bit of offset. So let's do 0.5. So you will start from 0 plus 0.5, then it will be 1 plus 0.5. So that should give them an offset. Let's try that. Should be multiplication. Let's try this. Yeah, because they all move by the same value. I think let's multiply it. So now they're too close. Let's multiply it by something greater. So 1.1. Okay, so now they're spaced out. And we made a line of objects using a for loop. So I can do that on x-axis, and I can also do the same thing on y-axis. So I can basically make a grid. And to do that, I can make a nested for loop. So I can make another for loop inside of here. For integer y position is equals to 0 and y position. So again, like I want it to be so 10 units. So my row will be 10 rows basically. And then yeah, I just want to increase my x position by 1. And that will be happening here. So you can see like altogether this script should run 100 times because it's basically 10 by 10. And I'm going to pass my y position into here, y position, and I'll multiply by offset as well, just like that. And let's hit play, and I should generate a grid just like that. So it should be 10 by 10. Yeah, 10 by 10. So you can see how you can make that dynamic straight away. So you can have, for example, you can expose your offset value, make that public. You can also change the so width and height of the grid by making that also public variables. So let's set width, and I'll set it to 10 by default. Let's make it an integer. So integer width is 10, and then let's do the same for height. Height is equals to 10. So, and now we'll pass them in here. So this is I believe my width, and this is my height. So now what I can do is if I go here, so I have all these values exposed. So if I press play, so I will generate this kind of grid, right? If I were to change, let's say, the spacing, so they are more spaced out, and I can change my width. Yeah, so my width is 3, my height is 10, and you can see they are spaced out in a different way. And I can quickly generate grids just like that, like whichever size I want it to be. So 3 by 3, let's make it something silly like 100 by 100. So that's a lot of things happening here. And so I'm just going to bring it back to 10 by 10. And so the thing is now is these, like each sprite exists like independently, like it was created but it was never stored anywhere. So if I want to store these values, I would want to make use a list. So let's write the public list of game objects. So this is the syntax for it, and I'm just trying to explain you how to think about it. So it's public list of game objects, and my list is called squares, and then it just needs to finish the syntax. So it's going to be a new list of game objects. So that's how the syntax of a list looks like. And I'm going to, well, at first let's just go back to Unity, see what's happening there. So we have our list. Right now there's nothing here, and I can populate it if I want to. You know, I can add objects here, but I want to add them into my list dynamically. So basically, every time I instantiate a square, I want to push it into the list. So for that, we need to make a variable here, game object. We can call it temp square, so temporary square, and we can assign it. So sorry, it's not game manager, it's game object. game object. It's temporary square. It's called temporary square, and the value is getting assigned here. So we're starting from the top left square, then the second square, then the third square, and I want to push each one of those squares as they're being instantiated into my list. So to do that, you write squares. So first you access the list, and then you write add, and I'm going to add temp square. Okay, so here I made another mistake. So I wrote game manager here. So, but that's a good lesson though, because so when you're pushing objects inside of array or list, make sure they are of the same type. So right now I'm trying to push a game object inside of a list full of game managers. So let's just change that, game object and game object. So now I will push correct type of data inside of the array. So we are instantiating it, which is happening here. Then we're storing it here, temporary, and adding it to the list. So let's try that. So right now I have 0 objects here, and I'm going to make a grid which is 10 by 10, and I will press play. And you can see I have 100 squares, and they all squared. They all stored in here, so I can access them and change something about them. So for example, let's do an update function. If I'll press space, so input dot get key down, key code dot space. So if I press a space, I want to go through all of the objects, and I want to make them let's say like a red or black. See what background color I have. So let's make them black, for example. So what I want to do is I can use a for loop, and it would look something like this. So for integer I, again I stands for index. So if I is less than squares dot count. So notice how when we used arrays, we used it was dot length, but when we're using so when we're using a list, we're using dot count. So if I is less than squares dot count, then I will increase. So that's like a little difference there. And so for each square, I just want to change its color. Squares I dot get component, and I want to make that access sprite render dot color, and I want to set it to color dot black. So we're accessing each element with a for loop and changing its color to black only if I press spacebar. So now here we have our squares, and I'll press space, and they will all change to black. So alternatively, if you want to change all of the objects at the same time, and you don't really care about order of the objects, you just want to change like everything inside of the list, you can use a for each loop, which is it could be like a little bit easier to execute if you want to change all of the objects at once. So for example, let's do it this way. If I press let's say A key, then they will all change to red. So I will just copy and paste that here. And so if I will press A, then I want to change them, all of them, to red using a for each loop. So for each, so we need to create a variable here. So I can either write a variable or it can be more specific. So it's a game object, I'll just call it, well, I can call it G or like temp square inside of the list I'm using. So my list is squares. So what we're saying here is like for each game object inside of squares, so like all of them at the same time, I'm going to take each temp square and I'm going to change it to let's say red. So get component sprite renderer dot color is set to color dot red. So let's save it and try that. So now if I press space, it will turn red. If I press A, it should turn red. So black, red. Like the slight difference is this. It's like here I'm just accessing all objects blindly, not in order. But in here, you know, I can do something with that I value. For example, I can use that as a like color, let's say. So I can pass it in here and like let's say what's the best way of doing that? Let's say color. So I'm going to create a new color based on the I variable, and so this is going to be my red channel. So red, green, and blue, and I'm just passing I inside of here. So right now, this is not going to be a nice color because you know, it starts with 0 and then it becomes 1. So we should basically have I think black square and then white squares. Let's see that. Yeah. So black square and then loads of white squares. But if I want to, I can perhaps divide that I by 100 so I can get more of a gradient. So right now I is an integer, so if I divide it by 100, I'm going to get a full value, not a increment value. So I want to store my I as a float basically. So I'll make color, so color component is set to I, and then I will pass that instead here, and I will also divide it by I don't know, let's divide it by 100 to begin with. Let's see what happens, because basically I want more of a gradient, like different colors inside of here. Okay, so I have created a gradient just based on their I values. So you can see, like if you're using for loop, you kind of have access to the order of the objects and you can do something with that. Whereas using for loop, you're just accessing all of them. Like, so this is the order of list. So, you know, it starts from 0 and it goes all the way to whatever your count of the object is. So in my case here, we have 100 objects. So, you know, we'll start from 0, 1, 2, 3, 4, 5, right? And based on that value, so if you remember, I'm just storing that value as a color component. And then I'm just dividing it by 100 because I want to have, you know, values between 0 and 100, so it's like a nice gradient, right? Because if I just put 1, everything is going to be black. So I'm dividing it a little bit, so well, dividing it quite a lot to have a gradient. And let's just run that again. And you can also, if you want to, you can make it in 3 dimensions. So if you want to make it in 3 dimensions, then you would simply need to, when you're generating it, you would need to add another for loop and send your object into, so use the Z position. So we can do that. So let's just write, so have width, height, and let's add another variable called depth. Okay, and I'm just going to copy and paste this here and rename variables. So this will be Z position, Z position, Z position, and in here I'm using depth. And now I just need to implement it in here. So it would be depth multiplied by offset. Sorry, not depth, Z position. So X position by offset, Y position, there we go. So I'm gonna save this. And I'm going to go into 3D mode and press play. And you can see I have a cube made out of little sprites. And if I press space, I'll change the color of them. If I press A, they will all become red. That's space. Yeah, you can change the colors. So I would say try it with for loop, but you can obviously do it, you know, give them individual script so they're changing colors on their own. But so I would make it like this if I wanted to change their color. Again, I would just use a for each statement here. And so right now, if I'll run it in update function, it will just make all of them red. But I want to give them different colors. So what I want to do is create a gradient. So public gradient colors. And I want to make my gradient to, let's say, from green to red. Something like that. So I can use that for, let's say, where am I? So an update function. So I can use a for loop, or maybe it's better if I use a for each. Let me just think about it. So let's just change color of all of them at once. So I'm setting a color and I want to change it based on my gradient. So it's called colors.evaluate, and inside of here I just want to pass in time. And I think let's make that into a cosine function. So mathf.cosine. So oops, .cos. So basically the value will go from 1 to -1, I believe. Let's try that. Yeah, so it goes from 1 to -1, so that's why it kind of like freezes on green sometimes. If you wanted to go use only positive values, you can make it into absolute value if you like. So mathf.abs. So this will give me only positive output. Yeah. So it's changing like that. And now, like I think it would be fun if they all change color at slightly different, like something like based on their position or maybe at different speed. So we can try to pass in objects, let's say x position, as a part of its value. So I'm just going to pass in square, so temporary square dot transform dot position dot x last time. So I'm passing is x value, and all of them have different x value. So let's just do that. So they all have slightly different offset because, you know, I'm putting position as a variable to change their color. And you can also pass, like, you know, so this is getting like really like a little bit out of hand here. It's really lengthy, so we can store that separately. So let's make it into a float, new color, and I'll store it here. So, and I'll pass it in here. So that's like maybe a little bit easier to read. So we have all of these things happening here, and let's say I want to pass my x position as well as my y position. So that way, I think the gradient should move diagonally. Yeah. And you can do similar things with, let's say, its scale and stuff like that. So let's do it. Transform.local scale is set to new vector free, and I want to change. Well, first let's see what happens if I pass my like color variable, because you know it goes up and down, so I might as well pass it, just see what happens. So I'm passing this float as a scale. Scale. Oh, sorry, I'm doing it on transform. It shouldn't be on transform. It should be on the temporary square object, which is this. So temporary object dot transform dot local scale, and I'm passing this changing parameter here. Okay, here we go. And again, you can do other things like rotation, position, so they can also be moving about. I think perhaps rotation would be fun. So temp square dot local, is it transform dot local Euler angles, and again I'll set new vector free, and I will pass in my new color as a value of rotation. And because I kind of know that this value goes between 0 and 1, like I'm already expecting that rotation here is not going to be that visible. But let's just try it. So yeah, I think they're barely rotating. I can click on the object and see what's going on. Yeah, they're barely rotating because they're going between 1 and -1, and as you know, rotation between 1 and -1 is basically insignificant, it's invisible, right? So I would want to, let's say, multiply each one of them by like a significant amount. Let's say multiply this by 10, multiply this by 20, and this by 30. So they all have like a higher rotation degree. And let's get back to Unity. Press play, go to the scene. So they are rotating, but I think I want to rotate them a bit more. So let's do 50, 100, and I don't know, 200, 300. Let's try that. So yeah, I think that's much more interesting. And the coolest thing about it is because we are using gradient, I can just change it, well, even on runtime, to like any color I want it to be. And it will be that color. Okay, so just experiment with that. You can see what I've done here. Again, maybe I should change my variable name because it doesn't represent color anymore. It represents like a dynamic shift for scale, rotation, and colors. So you can always double click on it, rename the variable, and I don't know, just call it like changing value, which literally means variable. But you can see I'm using it for all different things, so I might as well describe it better.